Hey guys, welcome to another video. Today we're going to be reviewing 5 questions for implicit differentiation and higher order derivatives. So the first question, they told us to find f double prime of x given this function. Now, so in order to find it, first of all, we need to find the first derivative. The first derivative is going to be in the form of u prime over u. So that means that f prime of x is going to be 4x to the power of 3 plus 1 over x to the power of 4 plus x minus 1. So this is going to be my first derivative. Now the second derivative is going to be according to quotient rule, because this is u over v. So f double prime of x is going to be u prime v minus uv prime over v squared, which is going to be u prime 12 x to the power of 2 v x to the power of 4 plus x minus 1 minus u, which is 4x to the power of 3 plus 1, and then v prime 4x to the power of 3 plus 1. Alright, now over x to the power of 4 plus x minus 1, all of it to the power of 2. Now, in terms of simplification, you can expand this piece over here, but keep it factorized. So it will be 12x to the power of 6 plus 12x to the power of 3 minus 12x to the power of 2 minus 4x to the power of 3 plus 1 to the power of 2 over x to the power of 4 plus x minus 1 to the power of 2. You can keep it like this, or you can even expand it even more to simplify it even more, but basically, yeah, that's the answer. But I'm not going to continue it because I don't have any more space. In question number 2, we need to find dy over dx. This is an implicit differentiation. Now, in the first piece over here, we know that we have to do product rule. So because this is u times v, so it's going to be u prime v plus uv prime. So u prime, it is going to be like y prime over y, because this is ln. So y prime over y, that's my u prime. V e to the power of 3x plus ln y, 3e to the power of 3x equals 8y to the power of 3 y prime. Alright, because 4 is going to go down, so 4 is multiplying 2, 8, and then the exponent remaining will be 3 y prime. Now the thing is, we have to keep the y primes together, so I'm going to move this term all the way over here. So it's going to be ln y multiplied by 3e to the power of 3x equals 8y to the power of 3y prime minus y prime over y e to the power of 3x. So then I have to take y prime as a common factor. So I'm going to rewrite ln y 3e to the power of 3x equals y prime, you open brackets, so you can cross out the y prime over here. What will be remaining? It would be 8y to the power of 3, and then minus, because you have a minus over here, and then if you cross out the y prime over here, you're going to get e to the power of 3x over y. So e to the power of 3x over y. Now, in order to isolate y prime by itself, we have to divide everything by 8y to the power of 3 minus e to the power of 3x over y. So y prime, it is going to be ln y 3e 3x over 8y to the power of 3 minus e 3x over y. And this is basically your dy over dx, because they both have the same exact meaning, just different interpretation. Question 3. if f of x is equal to x sine x, find f double prime of 0. So first things first, f prime of x, this is going to be a product rule, u times v. So it is going to be u prime v plus u v prime. That's my first derivative. And my second derivative, the derivative of sine x is going to be cosine x. And then the derivative of x cosine x is going to be u times v again. So it's going to be u prime v plus u v prime. So it's going to be cosine x plus cosine x minus x sine x. That's going to be your f double prime of x. So f double prime of 0 is going to be cosine 0 plus cosine 0 minus 0 sine 0. So this is going to be 0 over here. Now cosine 0 is 1 and cosine 0 is 1. So 1 plus 1 equals 2. Very basic, very easy. Question 4. Find the slope of the tangent at point 1, 2. So in order to do this question, you have to implicit differentiate again. So now the derivative of x to the power of 2 is going to be 2x. The derivative of y to the power of 2 is going to be 2y y prime equals for xy, again, product rule. For x is going to be my u and the y is going to be my v. So u prime, it's going to be 4. V is going to be y plus 4x y prime. So there's a trick over here that you can do. You can literally just replace the x and the y with 1 and 2 from here in order for you to find y prime. So 2, 1 plus 2, 2 y prime equals 4. 2 plus 4, 1 y prime. It's going to be 2 plus 4y prime equals 8 plus 4y prime. Now if you notice over here, there's something weird, because if you keep the y prime on one side and the numbers on another side, this is what you're going to get. 2 minus 8, because I'm going to move the 8 over here, is equal to 4y prime minus 4y prime. And this is going to give you that minus 6 equals 0, which is impossible. Therefore, there is no slope. The slope of the tangent is non-existent, or does not exist. In question number 5, they told us to find all the locations of the horizontal and the vertical tangents. So we're going to implicit differentiate first, and then we're going to keep everything in terms of y prime. So x to the power of 2, 2x. The 2x is going to be 2, and the 4y prime is going to be 8y y prime. And the 8 on that side is going to be 0. Now if you keep everything in terms of y prime, you're going to get 8y y prime equals negative 2x, negative 2. So y prime is going to be negative 2x, negative 2 over 8y. Now, the thing here is that a horizontal tangent, it means the numerator is equal to 0. So horizontal tangent that means negative 2x, negative 2 is equal to 0. So 2x is equal to negative 2. So x is equal to negative 1. Now, if x is equal to negative 1, I can literally replace it in the equation to find y, because they want me to find the location over here. So negative 1 to the power of 2 plus 2 negative 1 plus 4y squared is equal to 8. So negative 1 to the power of 2 is going to be 1. 2 times negative 1 is going to be negative 2 plus 4y squared is equal to 8. So 1 minus 2 is going to be negative 1 plus 4y squared equals to 8. So so y is plus minus, which is plus minus. So for the horizontal tangent, I have 2 points. Minus 1, 3 over 2, and minus 1, minus 3 over 2. For vertical tangent, the denominator should be equal to 0. So by replacing we replace y is equal to 0 over here. So we get a second degree equation over here. And let me get my calculator. So the first point and the second point, and these are for the vertical tangents. This is it for the video, guys. Thank you so much.